We know how to graph all of our exponential graphs. That's what we did in the first couple of sections of this chapter. So we can graph y equals 2 to the x, y equals 3 to the x, y equals 4 to the x. And for y equals log base 4 of x, it's going to be related to the exponential graph of y equals 4 to the x. And since I already know how to graph this one, we know that all exponential graphs have the point 0, 1. All exponential graphs have the point 1, and whatever the base is, in this case 4. We know that all exponential graphs have an asymptote at y equals 0, and we know their shape. So we could use this, if we wanted to graph y equals log base 4 of x, because log base 4 of x is just an inverse of y equals 4 to the x. So one way that we can graph log base 4 to the x is to first graph y equals 4 to the x and then graph the log graph after. And that will always work, but eventually I want you to just be able to graph logs directly, in the same way that you can graph your exponential graphs directly. And so just like all exponential graphs have the point 0, 1, all log graphs are going to have the point 1, 0. And if every log exponential graph has 1, whatever the base is, every log graph, if the base is 4, if I plug in 4 for x into my log graph, it's saying 4 to what power or 4 to what exponent is 4? It would have to be 1. And so you'll have the point 4, 1. If this graph has an asymptote at y equals 0, every single log graph has an asymptote at x equals 0. And the shape of your log graph looks like this. So identify any intercepts. Well, there's no y-intercepts, but we do have an x-intercept. We have an equation of our asymptote at x equals 0. Underneath here, I can write the domain. The domain x is bigger than 0 but not equal to 0 because you have that asymptote there. And our range, y can be anything. So now you can graph any log graph. Log base 3 of x would have 1, 0, and 3, 1. Log base 7 of x would have 1, 0, and 7, 1. You can even do, right, in our exponential graphs, remember we graphed e to the x? So now we can graph y equals log base e to the x. In fact, this one's so important that they never write it this way. They have a special way of writing it. ln. It's because with the base of e, it's called the natural logarithm. And I think this is French, log naturel, something like that. So the natural logarithm, if we were to graph it, well, all log graphs have the point 1, 0. And with the natural logarithm, since the base is e, we'll have the point e, 1. All log graphs have an asymptote at x equals 0. And there's the general shape. So you can graph any log graph. And so you're probably thinking, does that mean if we can graph any parent graph of log graphs, that we're going to have to do all the transformations with every log graph? Yes. Oh, the look of excitement on your faces. All right, questions for practicing the basic graphing ones, 10 and 11.